Hello friends, welcome back. Again we will be solving a question related to signal system, and this one is related to stability. Here he is asking whether the given system is causal and stable or non-causal and unstable or not. So to check for causality we need to see whether the response is non-zero for t less than 0. So if for t less than 0 h of t equals 0, then it's causal. Okay, so what we can do here is, because we know that anyways u of t plus 1 is equal to 0 for t less than 1. Okay, so for that it is 0 we know, but we don't know between for t minus 1. Okay, for but we do not know between t equal to 0 and t equal to 0 and minus 1 what is the value of h of t. So let us take a value in intermediate. So let us say h at we are taking at t equals to minus 0.5. Okay, so the value will be 1 over under root 2 minus 0.5 into u of 1 minus 0.5. So this is 1. Okay, so this value is equal to 1 over under root 1.5. Okay, and this is not equal to 0. So what we conclude is, for t less than 0 h of t is not equal to 0, hence non-causal. Okay, so we can say that it is non-causal because for t less than 0 the value of h of t is not a not 0, so it is some value. So the options A and option B both are ruled out because they say that it is causal. So these two options are ruled out. Now the options C and D are the options which are possible. So now let's check for stability. Okay, for stability of a system, what we need to check that is the system must be absolutely integrable. Okay, or the impulse response should be absolutely integrable. Okay, absolutely integrable means it should have finite value when you are summing it from the minus infinity to infinity. Okay, so it should be less than infinity. So here h of t already we know, h of t is equal to 1 by root t plus 2 u of t plus 1. So this is our h of t. Now we have to find whether it is absolutely integrable or not. So what you can do, we can again do the integration. Okay, so you can see that the integration is u of t plus 1, okay, dt. Now you know that this integration is non-zero, this h of t is non-zero for t more than minus 1, but for t less than minus 1 it is 0. Okay, so we can say this is h of t. H of t is, okay, non-zero for t more than minus 1 and it is less than 0 for t less than minus 1. So the limit can be further modified from minus 1 to infinity, 1 by root t plus 2. Okay, root t plus 2 into dt. Okay, because it will be this u of t plus 1 will be 1 for t more than equal to minus 1. Okay, now you can proceed with this integration and it's an easy integration. You can just substitute like t plus 2 equals to some value, or you can do it directly. You can directly use the integration property where we can put uh, this integration as t plus 2 raised to the power minus half plus 1 over minus half plus 1, and this is minus 1 to infinity. Okay, so this is under root t plus 2 over 1 by 2, and this is minus 1 to infinity. Okay, this is equal to 2 under root t plus 1 and minus 1 and infinity. Now this will, if you substitute this value infinity and minus 1, this will tend to infinity. Okay, because the root of t plus 2, as t will tend to infinity, or if we substitute infinity here, it will tend to infinity. So this summation will turn to infinity. Okay, hence system is unstable. System is unstable. Okay, so the option D is the correct option here. Okay, so what we did is, first we just check for the causality. For causality means for t less than 0, the system should not generate any uh, response, so it should be 0, and he saw that it's not 0, so the system was not causal. And second case, for checking for stability, we used the criteria that the response, impulse response, should be absolutely integrable, and which is given by this, which I'm highlighting again. Okay, this condition. And then we checked and we found out that it is also not a stable system. So this is how we need to proceed for questions like this. And thanks for watching.